in terms of revolutionary change, I think it's going to be these multispectral sensors and photonic integrated circuits and this move of spectroscopic sensing in general into everyday life.
Hello and welcome back to the Pittcon podcast. In this episode, we speak to Richard Crocombe about the advances in portable spectroscopy technologies. Thank you for joining us here today, Richard. Okay. So the first question is, could you start by introducing yourself as well as telling us a bit about your journey in the field of spectroscopy?
I did my PhD in inorganic chemistry and vibrational spectroscopy back in the era when everything was chart paper and highly analog. And as a postdoc, I used one of the early computerized FTIR spectrometers, which was an amazing step at the time. The specs sound completely bizarre these days. It had 32K of memory, and everything was on a 5 megabyte disk, the operating system, the software, your data, and everything. But it sort of laid the foundations for everything we do today in data acquisition and data processing and generating results. So all of the sort of search systems, the quantitative analysis, all of that type of thing was developed early on in those systems. So it was quite an exciting time. And I joined an FTIR company where I worked for about 20 years doing mostly applications development and instrument development, culminating in commercializing mid-infrared hyperspectral imaging using two-dimensional ray detectors, which was quite a feat at the time. At that point, I felt that field was getting technologically mature. I looked around, and I'd been looking at smaller and smaller and miniature spectrometers, because at the time, every spectrometer was what I call a 2-foot square beige box. The technologies were becoming available to shrink that down. I joined what was actually a telecom optics company that had developed a huge amount of miniature optical technologies. And we came out with a near-infrared spectrometer where literally all the optics were on a chip that about that big. Subsequent to that, I worked for other companies and used a whole bunch of different other miniature technologies. So I joined Thermo Fisher Scientific and worked with portable X-ray fluorescence, an elemental technique as opposed to molecular technique. But we acquired portable Raman and portable mid-infrared and portable near-infrared. And subsequent to that, I also worked for PerkinElmer, where PerkinElmer acquired a portable GC mass spec that's used in the field. So I got a very good grounding in all aspects of these portable instruments, the technologies, and the applications.
Yeah, perfect. Thank you. And obviously, you just mentioned there you've got extensive experience with spectrometers. And the next question is, what have been some of the most significant advancements in miniature optical technologies that you've witnessed over your career?
Yeah, I think the first wave was really all of the optics coming out of optical telecom, things like diode lasers and detectors. And in the 1990s, that certainly laid the foundation for portable Raman spectrometers, combination of diode lasers, optical filtering, CCD detectors, and again, the influence of consumer electronics, all the computing power and display that you have in your pocket on your smartphone. That's huge helped. Those technologies have fed into portable instruments enormously.
And in 2018, you did a review article in Applied Spectroscopy, was a comprehensive look at portable spectroscopy. How do you believe the field has evolved since then, especially in terms of technology and advancements?
Well, the first thing is it's grown enormously. Right after completing that article, I realized there was still a lot more to be said. And the outcome of that, in collaboration with Paul Leary and Brooke Kamrath, we edited what turned out to be a 2-volume book of about 1,000 pages and 40 chapters on the whole topic of portable instruments. So as these instruments get out into the field, maybe for one specific application, what happens is that people come along and say, well, can you do X? Can you do Y? You know, we'd like to be able to do this. And the manufacturers go back and you develop maybe another database, another calibration, maybe another algorithm, maybe some sampling techniques, but the core technology remains the same. And now you can do that application. And that sort of cycle certainly applied in portable X-ray fluorescence and in portable Raman, in that the applications of those instruments just grew and grew as they were out on the market.
Brilliant, thank you. And in your talk at Pittcon 2024, you mentioned the rapid growth of the portable spectroscopy field. Could you elaborate on what has driven this growth and what challenges have been encountered along the way?
Sure. Well, part of it is what I just mentioned in terms of this sort of cycle of getting an instrument out there, fielding questions about applications and developing them. But if you like, the photonics technology and the consumer electronics technology has continued to move very rapidly. And that's enabled instruments to shrink and shrink and shrink. As the engineers got more and more experienced in building these, and as all of these newer technologies fed in, they've managed to shrink the instruments while actually improving the performance, which is sort of counterintuitive. And so now you can get a portable near-infrared instrument that's the size of a computer mouse. It's got very respectable performance. The portable Raman instruments are about, the size of half a brick or something. Some are much, much smaller than that. And they're better performance than their predecessors. So that's really quite a triumph of the instrument companies and the engineers. And then they've also expanded all of the applications, as I said, with the libraries. The challenge is eventually you run out of steam doing that. As you shrink an instrument, just the amount of light, what the engineers call optical throughput, or ATON, that drops fairly dramatically, and that affects the performance. And so the next step is, the next generation of photonic type technologies. And there are a few of them out there which I sort of highlighted in the talk. So one of them is the availability of very low-cost multispectral sensors, not full-blown spectrometers, but multispectral sensors. And those are probably good enough for a whole bunch of applications. And I'll come back to that in a second because it feeds into consumer goods. And then the other new technology that's coming along that hasn't really been applied yet is what they call either silicon photonics or photonic integrated circuits. And we had a talk from a specialist in that area from Optica as the first talk in the session. And if you think about a conventional spectrometer, it's essentially a cube because you've got to have area in there to get light through. And that makes it difficult to, say, incorporate into a smartphone or something like that. The promise of photonic integrated circuits is that they can be planar. So everything can be on a plane, which means if you're integrating into a watch or some other wearable or a ring or a smartphone, it's much, much easier. And I think that's going to be the next step. And it'll take a few years for it to happen. Going back to multispectral sensors, those are cheap enough that they can be incorporated into consumer goods. And that was another focus of the symposium. So there are prototypes out there for putting, for instance, a spectroscopic sensor into a robot vacuum cleaner. You might think, well, no, there's a point of that. But it could tell what kind of surface it's on. Is it carpet? Is it tile? Is it wood? And it could adjust its operating parameters to do that. It could also spot stains and say, I have to brush here a little longer. And so there are ideas out there about smart toothbrushes, smart refrigerators. A lot of this technology is going into the existing wearables, sports watches and these rings and everything else. And so there's a lot going on there. And one of the themes of that symposium was maybe you're going to have spectrometers everywhere. You may not realize it, but you're going to have spectrometers everywhere in your life.
So you mentioned wearables in your previous answer, which leads perfectly onto our next question, which is about the application of portable spectroscopy in fitness products and health monitoring. Could you elaborate on how these applications are transforming the way in which we approach personal health and wellness? Sure.
If you look at some of these wearables, either smartwatches or the rings, they can do a number of things. They can measure pulse rate. They can measure blood oxygenation. They can measure tissue hydration. And so initially, there's been a lot of take-up of those from athletes who are worried about that, especially marathon runners and cyclists and things like that. And now it's percolating into everyone else's environment. And there's the thought that, you can sort of monitor your general health in these ways. And what's happening is that the developers of those devices are looking at extending the technologies. The Holy Grail, which we also talked about in the symposium, is optical non-invasive blood glucose sensing, getting away from finger sticks. People have been working on that for 30 or 40 years. It's a very, very difficult problem. But these more recent photonic technologies potentially can feed into that and help solve those problems. We may see products out there in clinical trials, in a few years' time.
Yeah, perfect. And, speaking of these new technologies, which do you believe holds the most promise for revolutionary change in the next few years? Is it the one you've just mentioned, or are there any more that you'd like to highlight?
In terms of revolutionary change, the existing sort of handheld portable instruments out there that are used by hazmat teams and the military and raw material identification, those are going to become more mature and everything. In terms of revolutionary change, I think it's going to be these multispectral sensors and photonic integrated circuits and this move of spectroscopic sensing in general into everyday life. The most bizarre example I gave in the talk was a concept of smart toilets, which sounds a little bizarre, but there is in fact one company out there with a product on the market already.
What's that product like? Can you tell us more about it?
It has a whole bunch of specific wavelength LEDs and receptors, and the concept is that it can, in real time, in situ, analyze urine and analyze stool, put that information up to the cloud, and then come back with, say, suggestions on how you can improve your diet and things like that. It's a little bizarre. And in the talk, I said we now come to the gruesome bit of the talk. But there are lots of ideas out there and all kinds of domestic devices. Another example would be smarter smoke detectors. So if you've got a smoke detector, if you're cooking a steak, it may go off. In theory, a smoke detector that's smarter and it has spectroscopic elements in it could tell the difference between that and, say, plastic burning. And so maybe it wouldn't go off when you're just cooking, but it would go off if there's a fire in your house.
Yeah, people wouldn't have to worry about burning the toast so much anymore.
Yes, exactly.
Yeah. So you've noted the significant cost reduction in producing multispectral devices.
Yes.
How do you foresee this impacting the accessibility and adoption of these technologies in everyday life?
Well, as I say, I think once you get down to some of the numbers that people are talking about, which is less than $10 per device bought in quantity, then you can incorporate them in household products and consumer devices, and certainly in wearables and rings and everything else that we've talked about, and smartphones. You can't do that if you've got a spectrometer that's that big and the cost of goods is $10,000 or even $2,000 or something. You've got to get down to those sorts of levels for spectroscopic sensors for them to be incorporated.
Pittcon Perspectives, unforgettable Pittcon moments from the experts.
So what do you find most valuable about attending and speaking at conferences such as Pittcon?
I think the thing that stands out about this conference is that there's a mix here. You've got the big instrument companies here, so you see all the latest instrument developments. You've got a large proportion of people, if you like, from chemical, pharmaceutical, related industries, and you've got academics. And so I think you've got that sort of cross-fertilization, which is very good, which you don't see in typical academic conferences. And there are other conferences that are much more just technology-based, and there are other ones that are just very academic-based. And this conference sits in the middle, and I think the breadth of its attendees and the talks is very valuable.
Yeah. And what are the advantages of Pittcon in terms of someone in the spectroscopy field?
Part of it is that is that you've got this mixture. The professional societies active in this field, Koblenz Society, Society for Applied Spectroscopy, Royal Society of Chemistry, they're all partners with Pittcon, and they help. They have input to the program in terms of organising symposia, and those societies also provide a lot of networking and a lot of contact making. So you add all that together and it becomes a very valuable experience.
Yeah, definitely. And as we mark the 75th anniversary of Pittcon, could you share your first memory or experience of attending this conference and how it impacted your view of the scientific community?
Sure. I'd been to, if you like, more conventional meetings beforehand. The first one I attended was actually in Cleveland, which really dates me in this community. If you look up when the conference was in Cleveland, but I was impressed at that time by this mixture of industrial practitioners and the instrument companies and the academics, and the cross-fertilization that happened. And I found that to be a very attractive and practical mix.
Yeah. And what have you enjoyed most about Pittcon 2024 in San Diego?
Well, the weather's a lot better than Chicago. That's certainly one thing. And the environment around the convention center is sort of very nice and everything. I think it's refreshing to come out to the West Coast, and it's a nice convention center.
And just the atmosphere is so much more sort of like lively because the sun's out and everyone's just happier and excited to get out there. Definitely.
Yeah, you don't need a parka to go outside.
Yeah. What are you most looking forward to about attending Pittcon next year in Boston?
Yeah. Partly I live in that area, so it's very convenient. But that there's a huge amount going on in Boston. The convention center is in what they call the Seaport area, which is a modern, completely redeveloped area. Again, very walkable. Lots of activities in the area and hotels. But you've also got obviously a huge academic community in the Boston area, and increasingly a very large presence of the pharmaceutical and biopharma companies in there. So again, I think you can bring together quite a large mix. And also, if you look at it, the headquarters of some of the biggest analytical instrument companies are in the area. So Thermo Fisher Scientific, Bruker, PerkinElmer, Waters, and that's like 4 of the biggest companies in the field. They're all headquartered in that area. So it would be great if they have a large presence at the conference as well.